Hey everyone, this is Miss Lastly and Miss Marker. We are starting our week 3 of online learning, and today we are doing factorials, which some of you may have not seen factorials for. Most of you probably haven't. This week we're definitely starting some new material that you really haven't been introduced to before, so I really hope that you pay attention, do your practice homework, and definitely join that live stream on Thursday to ask any questions, right? Because it is going to start getting a little bit more challenging. All right, Miss Markert, it is you.
Well, I hope you guys had a good spring break, doing nothing. But anyway, so yes, like Miss Leslie said, we are talking about factorials today. So by the end of this, you should hopefully be able to define a factorial, simplify a factorial, and just evaluate a factorial. So yeah, let's just jump right in. So a factorial is just an integer. Ooh. Hang on. It's not gonna upload. Why are you not uploading? Sorry, guys. Well, while my computer's thinking, an integer, a factorial is just an integer, and all of the integers before it multiplied to that integer. So if you had, say, 5 factorial, for example, you would have 5 times 4 times 3 times 2 times 1. So,
all right, guys, we had to take a pause. We had some technical difficulties, but I think everything is working now. So here we go again.
Okay, so an factorial is an integer. There we go. Now it's working. An integer n times all of the integers that come before it. So, and the symbol for a factorial is an exclamation point, which I know doesn't look like a math symbol, but surprise, it is. And we write n factorial, for example, as n times n minus 1 times n minus 2. And then we continue till we get down to 2 and 1, which is our last two integers that we have. Because remember, an integer doesn't include 0. It's just the whole numbers. Yep. Okay, so for example, if we have 5 factorial, we would have 5 times 4 times 3 times 2 times 1, which would equal 120. 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1, and this would equal 720. Now, this looks kind of annoying to do by hand, and if you get something like, I don't know, 13 factorial, it's kind of annoying to do by hand, so there is a way to do it in your calculator. So you press the math button, and then you scroll over, you use your arrow keys to scroll over to the top part that says prob, and you want to select number 4 as the option. And so you type that all in and then hit enter, and it will give you what your factorial is equal to. So it makes it super simple. Another way that you could have done number 6 too is if you know that 6 factorial, you know you're working with 6 factorial and you just figured out what 5 factorial is, you can always just take 6 times 120 because 5 factorial is part of it. But to make it a little easier, because you've already done the work for part of that. Okay, so the next thing we need to talk about is how to break up a factorial. So factorials aren't just numbers, you can have variable factorials. So to break up a factorial, you want to take, so n factorial, just whatever, would be equal to n times n minus 1 factorial. And then you can also write it as n times n minus 1 times n minus 2 factorial. And this is going to come in handy when simplifying things. It will come in handy when simplifying ones with variables, ones without variables that are just constants, like the two examples we have below. So let's do this first one. So this first one, that top one should be 98 factorial. So the top one is bigger than the bottom one. So we're going to expand the top one and then see what we can do from there. So let's expand the top one. So if we have 100 factorial, we can expand that to be 100 times 99. So remember n minus 1. So 100 would be n, 99 would be n minus 1. And then we can do, let's go one more. So let's do 98. So n minus 2 and then factorial there. So because we have a 98 factorial there, we can just write like that. And then those factorials cancel out. So the 98 factorial on top and the 98 factorial on the bottom, those will cancel out because they're the same number. So we would have 100 times 99, which is equal to 9900. And that would be our answer for number 1. For number 2, we're going to do the same thing. So we're going to take the bigger factorial and we're going to expand it. So the bigger one in this case would be the denominator. So we are going to expand that one. So we're going to take n. So n is n plus 2. And we're going to do n plus 2 minus 1. So that would be n plus 1. And then we're going to do n plus 2 minus 2. And that would be n factorial. And so remember, we have n factorial and we have n factorial on both top and bottom, and those cancel out as well. So our simplified version of this would be n plus 1 over n plus 2 times n plus 1. And then we multiply that out and we get n squared plus 3n plus 2. Did I miss anything, Miss Lastly?
No, I think that's good. Just remember when you're simplifying those hard ones, just like Miss Markert said, you want to start with the one that's the biggest and you want to pull it apart until you get to where you have the one that's the smallest, right? So in like number 1, 100 is bigger than 98. So we want to simplify 100 down to 98, right? Just by pulling off the pieces that came before it. And number 2, n plus 2 is bigger than n. So you just want to pull off the pieces that are going to be bigger so that you eventually have it down to where it's equal. And remember, the reason we can cross these off, like the 98 factorial over 98 factorial, is because it's all multiplication, right? It's 100 times 99 times 98, down, 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 right? If this was a plus, we could not cross these off. So don't start crossing stuff off that's not allowed. But because it's all multiplication, you can simplify. But yeah, so that's basically what you have to do. Just be careful. Remember, you always want to pick the bigger one to simplify. You don't want to try and make something that's smaller and try and make it go up because it doesn't go up.
Mm-hmm.
Yeah.
Yep. And we're not going to go through any homework today because it's pretty much what we just did. And we want you to practice since this is new. So, yep.
Yeah. All right. So just practice your homework, guys. Remember, your homework is not actually getting checked. Like, we're not checking your homework, but it is a good idea to do it because a lot of the problems that I'm putting on these end of the week checkpoints do come from questions from the homework. Like, they're very similar. So if you're not practicing the homework, at least doing a couple from each day, then you're going to have a really hard time on that end of week checkpoint. All right. So, yeah, hopefully you guys enjoyed factorials. If you've seen them before, great. If you haven't seen them before, hopefully this was a good intro. Remember, we'll have that live stream on Thursday for any of you guys that have questions still on this stuff, but hopefully it wasn't too bad.
Factorials are kind of fun, I think.
Yeah. Yeah. think they're pretty fun.
Yeah.
But yeah, so until tomorrow, bye guys.